Welcome back to DevOps, Git Started. I'm Raheem Kareem, and in this episode, we're diving into the tool that keeps developers from overriding each other's work, Git. Whether you're coding alone or as part of a team, version control is your foundation. It tracks your changes, gives you a safety net, and makes collaboration seamless. Git is a distributed version control system, which means every developer has a complete copy of the project history, not just access to a central server. It works like a series of checkpoints. You make changes, stage them, and commit them with a message. These commits stack up, forming a history you can review, branch from, or revert to.
All right, developers, before we write more code or talk about tools, we need to understand how Git actually works. This blueprint is the Git repository workflow framework. And once this clicks, Git stops feeling confusing and starts feeling powerful. Everything begins in your workspace. This is your local machine, your editor, your files, your experiments. Nothing here is tracked yet. You're free to break things. When you're ready to save progress, you don't commit immediately. You move changes into the staging space using Git add. Think of staging as your review area. You're intentionally selecting what goes into version history. Once staged, you commit. That snapshot is now stored in the local Git repository. This is where Git's real power lives. History, rollback, comparison. And when you're ready to collaborate or back things up, you push those commits to a remote repository, usually GitHub. Now, your work is visible, shareable, and protected. And Git isn't one-directional. You can fetch, pull, or merge changes from others back to your local repo. That's how teams stay in sync without overriding each other. This loop, workspace, staging, local repo, remote repo, is the heartbeat of DevOps version control. Master this flow and everything else in Git becomes easier.
Here are your essentials. Git init, start a repo. Git add, stage changes. Git commit, save them. Git push, send them to GitHub. Git pull, bring in new updates. Remember these, because we'll use them in almost every episode ahead.
Git is incredible, fast, distributed, and built for code. But it was never designed to handle large binary files. That's where developers often run into trouble. If you've ever tried uploading a large file to GitHub, videos, datasets, models, you've probably seen this fail. And that's not a bug, that's Git protecting itself. This is where Git Large File Storage, or Git LFS, comes in. Git LFS